Hey everyone, thanks for joining me. This is Alex. So today I have a special treat for everyone. Recently I have been developing and building my own do-it-yourself gene gun, and I've had a more or less successful time with it. I'll talk about some of the drawbacks of a homemade gene gun in a little bit. However, due to some stroke of fate, I received a new in-box, completely untouched Helios gene gun that you see before you from a very generous donor. So thank you very much again. I can't even say how much this means to me. But the reason that I find this pretty special is that even to this day, this is pretty much the top of the line or state of the art when it comes to particle bombardment. So this is known as the Helios gene gun. It's manufactured by Bio-rad, and what it does is it essentially shoots gold beads that you've coated in DNA. So this is just gold dust, gold powder that you coat with DNA. You fit into this sort of revolver-like cartridge, and then you place it inside the gene gun, and then you can, shoot it at plants or animals or whatever you want, really. And yeah, I've been lusting after this for quite some time, just because it is the top of the line, and Bio-rad is really the only company that makes gene guns, at least legitimately. I'll talk about it a bit later, but it seems that just recently copycats have been coming out of this gun, but we'll cover that in a bit. But this gun in and of itself, like the full kit, costs $30,000 American, plus taxes and fees. You could be looking at upwards of $35,000. So I have not actually used this for bombardment yet, because unlike the homemade gene gun, you need an external gas tank of helium and of nitrogen to actually make this work. And I'll talk about sort of the pros and cons of that later. But basically, how the gene gun operates is, first of all, you have a fitting that goes to your helium tank, and there's a nice swage lock fitting on the end here. That's a quick connect, quick disconnect, and you just plug it on in, snaps into place, and then you're good to go. It's interesting, or I suppose encouraging, that their choice of fittings are stainless steel swage lock fittings, just like the ones that I used in the homemade version. So again, kind of encouraging that I'm using the same fittings that the pros would use. Come on. There you go. So the helium gas actually enters through here, and then it's controlled by two solenoid valves that are inside here. We will be taking this apart to give you a better look, but just for the brief explanation, if you go no further, there are two solenoid valves in there that are controlled by electronics. You don't really have to be an electronics guru to understand what goes on in there, but basically this is powered by a 9-volt battery, and I'll put one in right now. And the way, I think the theme in this gene gun is it's basically good enough. I mean, I was expecting, my hopes were really high for the quality of the gene gun for $35,000. However, there are a couple of disappointing parts. I know it's kind of finicky, but the battery compartment for this expensive equipment, there's no sort of lock. You essentially slide in this piece of metal that holds it down with spring pressure of the battery clip. So it's pretty hokey, you know what I mean? Anyways, and I mean, it holds it fine, it does the job, but it's also really funny when you remove the battery, it kind of just goes flying. Come on. But anyways, so when you insert the battery, what the gun starts to do is it starts charging two internal capacitors inside the gun here, which we'll take a look at. And it shows this with the indicator lights. There's charging, charge, armed, fire, and so forth. Before you can fire this gun, you need to press the safety switch here. and it basically has a very dramatic way of telling you that it's, you know, active, ready to fire. So I'm going to press the safety right now, and then I'm going to fire it, and hopefully you heard the solenoids actually actuating. So what this does is it takes the helium and it shoots it through your little revolver-like, what do you call this, cartridge, and there are individual bullets in each of the holes. And then when you want to go to your next target, it's again very much like a revolver. You press this big old lever, and it advances to the next position. The barrel itself is removable. It's made of plastic, pretty nice plastic, but plastic nonetheless. Some sort of glass reinforced stuff, and it actually comes with, I think, 5 of these. So if you were shooting different plasmids, then you'd want to use a new barrel and also a new cartridge holder every time to prevent cross-contamination. But that's what the barrel looks like. We'll sort of compare it with my updated barrel as we go further, but I just wanted to get the brief introduction out of the way. Another thing that I don't really like, again, I wasn't super impressed, this actual lever arm, you know, this looks cool, but it feels really, really flimsy. It's a heavy piece of gear, but the actual, the plastic, it's not, you know, glass reinforced nylon or something like that. It, I don't know, feels like an ABS or something like that, so pretty cheap. The arm, it does the business, but again, it's not really connected at the bottom. It's, yeah, it feels kind of cheap, at least this specific part. But with that griping out of the way, let's actually get into it and see what it looks like on the inside. If you do plan on doing this, and frankly I don't really recommend it, I'll try to put up some decent pictures online so you can see how it's made, but there's nothing really user serviceable inside. I mean, you could play around with it, but if you take it apart too much, I've got a feeling that it'll be almost impossible to put it back together. So I'm gonna at least pop this cover off, show you all the internals, and draw you a bit of a diagram of what I think is going on. However, I won't tear it down too deeply because frankly I want to use this for actual experiments. But let's get into it. We'll come back when I unscrew these hex bolts with a 1/8 inch hex key, because this was made in America. Okay, so I've removed all the screws from the front and the back. What's sort of annoying is that, you know, this thing was never meant to be serviced by the user or maybe anyone. So you actually have to peel off the status indicator sticker that goes on here. Also, you're gonna find that once you pop the shell off, this little piece is gonna go flying, and what it does, it is actually a spacer for the LEDs on the indicator. So just keep that in mind. If you find an extra piece after you've taken this apart, that's actually where it goes. So we'll put that back in the end. But let's pop the top off and take all those buttons off. And as you can see, hold on, I have to disconnect some wires. Okay, so for whoever actually does this again, there are 2 little connectors that you have to unplug before you take the whole unit out. But once you do that, it all comes out rather nicely. And so there we have it. That is what $30,000 buys you. So let's just take a look at the path of the helium. I mean, I'm not so much interested about reverse engineering, you know, the electronics or anything like that, because, you know, quite frankly, these days you can do all the control of this gene gun with a $10 Arduino knockoff and some transistors. So the actual electronics aren't super important. Like I said, you can get an off-the-shelf solution. What's more interesting to me is actually how the fittings were designed and constructed. And as you can see, basically it's stainless steel throughout. The parts where basically you have swage lock fittings, which are a type of compression fittings, and anywhere that you have threads, they're actually sealed by Teflon, which looks like it's good enough. Interestingly and encouragingly for me, you can see that even in professional manufacturing, it looks like for stainless steel tubing, it's totally okay to do a brazed solder joint of silver to connect stainless steel. And as we'll cover a bit later, I also used silver brazing to switch out for the epoxy on my own gene gun. So it looks like we have the stainless steel tubing with the helium going up there. One other little nitpicky thing, if this will ever focus for me. Come on. Is you can see that when they were turning the threads on this piece of pipe, there you go, they obviously did it in a lathe, and when they put it in the lathe chuck, they didn't use soft jaws. So you can see that the jaws of the lathe actually left, pretty significant grooves in the pipe. And while I don't think this will, make this any less safe or anything like that, I just think it's a sloppy detail for, again, a high-end piece of equipment. So the helium goes up the tubing through this custom machined stainless piece, which then connects directly to this block right here. Now what does that do? I think this is going to be some sort of expansion chamber for the gas to allow the gas to expand and probably lower in pressure a little bit. One thing to keep in mind, as far as I can tell, there's actually no transducers or anything like that inside this. All the pressure regulating that's done is done at the beginning of the loop. So this, attaches to the hose, and the hose connects to a helium regulator. So I don't think there's actually any sort of sensing going on in the gene gun. So the helium goes to this gas expansion, for lack of a better term, gas expansion space, and then it feeds into two solenoids. And if you want to take a look at the part numbers, come on. There they are right now, and as you can see, they are Parker fluid control valves, 6-volt DC. And what's kind of interesting is that these solenoids are rated for only 600 psi versus the ones that I use are rated for 1000 psi. Technically, in the manual, it states that you can go over 600 psi, but I think under normal operation you're going to stay under there. But whether they chose a lower psi rating because it's not sustained, I'm not sure why. So it seems a little bit underpowered. However, this is probably, it wouldn't blow up probably until 2 or 3, 4,000 psi. So it's not like this is unsafe. I just think over 600 psi, this valve may not operate correctly. But there's two of them. So from the gas expansion tank, it goes into one and into the other. This one, I just think it's a vent. The outlet doesn't actually go anywhere, so it just vents into the body of the gun. So this is to probably relieve pressure after every shot. Whereas this solenoid is actually what's going. Oh, no, you know what? I was wrong. I think this is some sort of, I don't know, reservoir. So it looks like these guys are only for regulating the pressure. There may be another solenoid in there because this one vents just to the environment. And this one is connected through a small stainless tube right back to the beginning again. So perhaps it's, I'm not a gas operator expert, okay? I'm no AVE, so I don't know really what's going on, but I'm going to guess that this tubing is feeding back here to sort of equalize the pressure within the system. I think there's a check valve in here, so yeah. So these guys are essentially just doing some sort of pressure regulation and just letting off any excess pressure after every shot. So there's likely another valve in here which actually releases the gas and shoots it through your bullet. And I will take a look at this a little bit more carefully and try to draw a diagram. I'm just, this is actually the closest I've looked at it, so it's kind of new to me. But yeah, as I said, it's encouraging that I'm basically using the exact same style of parts and construction that the professionals use, which makes me feel like the gene gun that I'm making is safe to use. I did say that the electronics weren't too important, but as you can see, to get away with not having a external power supply, so not being connected to the wall, the 9-volt battery actually charges up these two 16-volt capacitors, and these capacitors, obviously very nice quality, Nippon Chemicon. These guys are what actually drive your solenoids. So the 9-volt charges these guys, and the capacitors are themselves controlled by likely this is a microprocessor, and just for, because we're already in deep, right? So we might as well see what kind of microprocessor these guys use. I think this design is over 10 or 15 years old, so maybe a pick. Hold on, I'm just gonna look at it closely. Yep, called it. It's some sort of PIC microprocessor, and it's standard. There's no real magic here. Like, anybody could design this kind of board. I think most of the magic is actually within all the, I don't know, what do you call it, pneumatics of this whole thing. But yeah, so let me take a bit of a closer look and try to draw a diagram for you guys of how I think this is working. Then we're gonna put it back together and take a look at what I've sort of improved on in my gene gun. So hope you enjoy that look. I'll be posting some close photographs in focus on the actual blog. But besides the marring on here, and they didn't really bother too much to clean up that, it's pretty decent construction. But again, I was sort of expecting more. Again, this arm feels sort of cheap, and the way that the clamshell this goes back together, the edges don't actually fit properly, and it's not just because I put it back together wrong. They legitimately don't fit together very well. And when I took it apart, I actually found quite a bit of aluminum shavings that obviously come from the tapping operation they did to actually secure everything together. So, I mean, I realize these are made in small volume, but and probably by one or two people. Realistically, it's is not more than a garage operation. But I don't know. I think they could have done better. Okay, so let me draw a diagram and take everything I say with a bit of a grain of salt. I'm not a, not a hydraulic, pneumatic design specialist, but basically what I have here is a, what you'd call a block diagram, a rough diagram of what I think is happening inside this gene gun. So, first of all, we start off with our helium tank, excellently drawn, and the tank is hooked up to a pressure regulator. So there's no actual control of pressure. The way that you set the pressure of the gun is at the helium tank. So the piping, the tubing goes and it hits the quick disconnect, and what I think, so it hits the quick disconnect, and what I think is some sort of valve. Now, what I originally thought happens is that the helium gas is meant to go up this thick pipe, but I actually think that this thick pipe is the return to equalize the pressure. So I think the helium is actually going to, at least to enter the business side of the gun, is going to go up this skinny little tube. So that's the path that we're going to follow here. So some sort of valve, maybe a check valve. I think there's a couple of check valves in here. And it goes and it's stopped by the first solenoid. So the solenoid is controlled by the microcontroller. It's the little computer inside. Nothing too fancy. And basically the microcontroller senses whether the safety switch is depressed. There's one optical sensor to make sure you can't fire it when you have the when you have this thing out, the carrier. And then you finally have the trigger that actually that the microcontroller uses to sense when you want to fire. So, and then the capacitors actually discharge and turn on and off those solenoids. So when you hit that safety switch and you hit that trigger, basically it actuates solenoid 1, which opens up sort of like a valve, like a switch. So the helium gas travels through the solenoid and it can go one of two ways. So it can go into the firing chamber or into the second solenoid. So let me just show you that. So as I said, I think it's this little tube that's carrying the main pressure, I guess. So the little tube goes all the way around into here and into this first solenoid. So once you hit that trigger, this switch, it's a switch. This switch opens, and then the helium goes either into the firing chamber and into your gene gun cartridge, or this little T connector goes back into the second solenoid, and then the second solenoid just and then it just vents to the outside air. This is enclosed inside the gun, so it's not like it's gonna depressurize right in your hand, but there you go. Yeah, so it just comes out of there. So basically that's what I think is going on. Once this solenoid is actuated, there's a certain amount of, it's actuated for however 50 milliseconds, let's say, and then the helium goes into the firing chamber and through the barrel and boom, right? I think as soon as this is finished firing, you simultaneously also have the second solenoid venting the excess pressure to the outside. And then I also think you have some sort of feedback here to equalize the pressure. Focus. Now, when this actually happens, I'm not quite sure yet. It's possible that this link between the firing chamber and which is this thick tubing, I thought that this was the main inlet of helium, but I think this is literally just to equalize the pressure. Perhaps when you disconnect the gun, it's to equalize the pressure with the firing chamber. Again, I need to think about it a little bit more carefully, but that's what I think is happening. So yeah, I think that's basically the sequence of events. You have your helium through this check valve, through the solenoid, which is controlled by the computer, and it goes through the firing chamber, through your barrel, sending your gold bullets flying, thence to the outside, and then also equalizes the pressure. So nothing really too complex in this thing, Okay, so there's the Helios gene gun, but how does it compare to the new version of my do-it-yourself gene gun? So I call it the awkward adolescent stage, or the Mach 2 stage. So it's grown. One of the things you'll notice is that I have significantly extended the path from the CO2 cartridge to the actual gene gun. And I did this because I replaced the manual sort of valve that you use to turn on the flow of CO2 into the firing chamber, one that goes, nee, 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 with one that you can control with a computer with relays or transistors, relays in my case. But yeah, essentially, if you have your CO2 too close to these types of solenoid valves, they'll actually freeze open, thereby sort of defeating the whole purpose of having them there in the first place. So that's why we have this sort of abomination right here. The reason that I added this solenoid is because essentially what this can do is, in the program, I can tell the computer, okay, pump up the firing chamber to, let's say, 400 psi. So it will turn this on and off a couple of times, give pulses of CO2, and it will read its own pressure with this transducer that I got off eBay for maybe $5, and with a wire it connects to the Arduino. So basically, the program can actually pump up the firing chamber to a specified PSI, which I thought would be quite convenient, at least in theory. It doesn't work as well as I thought it would, because without a regulator after the CO2 cartridge, the control of the solenoid isn't fine enough to get 10 or 20 steps per pulse of the solenoid. You get more like 50 or 100. So the control is pretty coarse, and as the level of CO2 drops in your tiny little cartridge, then every pulse of this solenoid also gives less overall pressure. So ideally, you would actually hook this up to a CO2 tank, but it sort of defeats the purpose of having it in a sort of a compact format. But that was the idea, and it works reasonably well. At least it allows me not to mess around too much with another valve and sort of mess with these fittings, so I can just tell it to pump up to a certain PSI, and then you're good to go. Now, the second major improvement I made to this gun is, as you remember, the barrel that threads on here and holds your cartridge. I was pretty embarrassed last time, but I wanted to put it out anyway. I had a big blob of epoxy on it, but what I did was I actually silver brazed these two fittings together, and it's actually an extremely strong joint. So just from the little reading I read, the minimum sort of conservative value for tensile strength is about 20,000 psi tensile strength of this material, about 50% silver and other herbs and spices. And this worked out quite well. It looks good, nice and shiny and strong. And it's the bond of the metal is actually it bonds at the atomic level. So at this interface of silver and steel, it's a one alloy basically. So it's a good joint. And again, since we saw the same silver brazing in the Helios gene gun, I feel much safer using this. So I'm happy with this, and I'll leave it there. One thing to know: this isn't my first attempt at this. I did try stick welding, and you guys might be laughing because stick welding thin stainless steel is, at least for someone of my skill, basically impossible. But I did give it a go, and I produced this abomination, and it's probably the ugliest thing I've ever created in my life. So not only does it look like, I don't know, something disgusting, but it also blew through on the inside since this steel is so thin. So yeah, don't do that. But anyways, I'm happy with this raised joint here. One thing that I would like to improve is I want to copy the Helios barrel in the sense that they have a much wider opening for the gas to actually escape and for the bullets to keep traveling. So what I'm going to do is I'm going to basically duplicate this design on my 3D printer such that it just bolts onto here instead of this sort of in whole piece. So that's basically the improvements I've made on the gene gun so far, at least in terms of its mechanical construction. One thing I did change, as my reporter gene, instead of a green fluorescent protein and looking at it under a microscope, I switched to using the GUS assay. So I fired the GUS plasmid encoding for GUS onion epidermis. And basically, if you have successful transformation, the cells that are transformed turn blue when you apply a specific chemical to them. So it's much easier visually to see if your gene gun works if you have sort of like a color change versus having to set up a microscope and looking at fluorescence and that kind of stuff. So that I find easier for optimizing a gene gun, just because you don't want to be second guessing your microscope skills while you're troubleshooting this new thing, right? The major drawback of the DIY gene gun is if you're doing any sort of quantitative work downstream, it could not be the best choice when compared to the Helios, because the main limiting factor, at least from what I can tell, is the fact that when you coat the pair film with your tungsten and DNA, it's pretty difficult to get an even coating without the tungsten beads sort of clumping together, which impacts sort of your shot per shot consistency. So if you were doing, qPCR downstream, you may not want to use something like this, or just optimize it like crazy. The Helios gene gun, on the other hand, it has quite an elaborate system for gene bullet construction. So basically, you have to get this huge monstrosity called the Bio-rad tubing prep station, and essentially what you do is you have a piece of Teflon tubing and you thread it through this aluminum rod thing. It has a cutout for it. You switch it on and it starts to rotate. At the same time, you apply some nitrogen, a small or a slow flow of nitrogen through your tubing, and this essentially dries your tubing and it coats the insides of the tubing evenly, and then you chop it up and then you load it into your cartridge. So this seems like a nightmare to me. I haven't done it yet, but I think the first time I'm going to do this will probably take me, 2 or 3 hours, versus making 20 or 30 gene bullets would, I could do that in 45 minutes to an hour. So that's where I think the Helios gene gun is going to be superior, and it's going to be in the shot per shot delivery. However, if you don't really need consistency, or you obviously need consistency, but if you're not doing anything quantitative, like if all you're doing is you're building a gene gun to infect plants with a virus, then the DIY option is fine, because even if the efficiency isn't great, you're still going to get an infection, and that's going to propagate itself. So that's essentially it. That's my comparison of the homemade versus the commercial gene gun. I'll post some high-res pictures of the insides of this guy, and hopefully you enjoyed that. And the whole reason I do these sorts of videos and blogs is that I want everyone to know that there's no magic inside these things. There's a lot of hard work that goes into making these, sure, but a human being actually made this, and therefore you can too. So I hope you enjoyed watching the video, and leave any comments if you like, and I hope you have a nice day. Thank you.